right, thanks, Valerie. Now, besides you guys seeing the slides, the other trick is to see if I can see them while I'm talking. Okay, so I'm Scott Rotondo, Principal Engineer in the Solaris Security Group, and I'm going to try to tell you everything you need to know about Solaris privileges in 7 slides, which means this is necessarily going to be pretty superficial. I'm going to try to hit the high points here. Happy to take questions or explore any part of this in more depth afterwards. So first slide just gives an introduction to what the privilege system is all about in OpenSolaris. In traditional Unix systems, a process basically is either able to perform any privileged operation if it's running with user ID 0, or it has no privileges associated with it if it's any other user ID. And within the kernel, all the privileged operations involve a check to see is the user ID 0 or not to decide whether the operation should succeed. In OpenSolaris instead, we split this up into a whole bunch of fine-grained privileges, 75 of them at last count. And this breaks up that super user capability into individual privileges to control whether you can override file permissions, open a reserve port, use dtrace, as we heard about in the last BOF, anything that would be a privileged operation. And in the kernel, when we perform a privileged operation, instead of checking for the user ID, we check to see if the process has the specific privilege that's needed. And so that means that a process can have any subset of those bits and pieces of root capability that it needs, and the root user ID is not special at all. It's just another user. Now, when I get to the last slide, you'll see that last statement isn't completely true. There's a little bit of exception to that, and I'll talk about that. But for the moment, you just assume root is treated like any other user, and what controls what a process can do is what privileges it has, and that lets us implement what's usually called the principle of least privilege, the ability to give a process only the capabilities it needs to work correctly and nothing more, so that if it's later subverted somehow, or if it contains bugs, its misbehavior is bounded by the privileges that it has. So the next slide, which just changed automatically for me. Okay, the next slide, which I hope you can see over there, is a diagram of the privilege sets that a process has. As it turns out, we have not just one, but actually 4 different sets of privileges associated with a process. And normally when we talk about a process having some privilege or not, we're talking about the effective set. That's a set of privileges that are currently in effect for this process. When it goes to perform a privileged operation, we check to see if the necessary privilege is present in the effective set of the process. The permitted set is an upper bound on everything the effective set can contain. So the effective set is always a subset of the permitted set. And the next slide, I'll talk about why that's a useful thing to be able to allow us to turn privileges on and off in the effective set. The inheritable set is what gets used when this program execs a new program. That's the set of privileges that that will be the initial permitted and effective set of the new program. And then the limit set, kind of like the permitted set, is an upper bound of all the privileges that this process can have, but it's an upper bound of the permitted set for this process and all of its descendants. So if you take privileges out of the limit set, not only does this process not have them, but none of its descendants can ever acquire those privileges. And so next slide shows how we make use of this. Basically, processes can freely remove privileges from any of their sets, and can add privileges as long as they still respect that subset relationship I described. So you can turn privileges on in your effective set as long as they're already present in your permitted set. And what this is used for is a thing we call privilege bracketing. If you want to take the principle of least privilege a step further and arrange that not only does the process have only the privileges it needs, but only the code that particularly needs to run with privilege has those privileges. So a typical thing to do is use the setppriv system call, turn on the privileges you need, perform the operations that need privilege, and then turn the privileges off. This is actually exactly analogous to what a traditional Unix program would do. If it was setuid root, you would toggle the effective user ID, set your effective UID to 0, do whatever needs privileges, then set it back to the real user ID. And so this privilege bracketing works the same way, but again on a more fine-grained basis with individual privileges. And then at the bottom of the slide, you'll see an interesting pattern that comes up very frequently in programs is that they need a certain set of privileges when the program starts up and initializes, and maybe opens a socket using a reserve port, or needs to open some files or something like that. So it may need to use privilege for some of those operations, but once it starts up, it no longer needs any of these privileges. And so then the thing to do is to not just turn off the privileges, but to permanently drop them from the privileges the process can ever acquire. And that's where it's useful to be able to turn off privileges, not just in the effective set, but in the permitted set. Once they're turned off there, they can never come back in the effective set because it's always a subset of the permitted set. Next slide talks about something we have in OpenSolaris called basic privileges. And these are the privileges that are used to control operations that ordinarily you wouldn't think of as privileged. These are operations like forking another process or executing a program. Things that ordinary unprivileged programs can normally do. And in fact, user processes have all of these basic privileges in their permitted and effective sets by default. But the reason we have them as separate privileges is so that we can turn them off. We can make processes that are even less privileged than normal. And this is useful for a daemon, for example, that never needs to fork a subprocess. So you can turn off that that privilege, and then no matter what happens, no matter how the program is subverted, it can never fork a shell, for example, because the fork command will fail. And so there's a list on the next slide of the current basic privileges. There are 5 of them. I won't bother to describe them in detail. I already gave 2 of them as examples here, but you can see that these are all things you wouldn't normally think of as operations requiring privilege, but they are operations that we sometimes want to be able to take away from a program that we know doesn't need them. So next slide talks about how a process acquires privilege, and really there are two main ways. The role-based access control, or RBAC system, consists of profiles that can be associated with users or roles, and these profiles have lists of commands and specify the privileges that those commands should run with. So a user using one of those RBAC profiles, like the example on the slide here is the process management profile, lets you control other processes on the system, so it allows you to run the nice command with 2 privileges that you need in order to affect other processes. The proc owner privilege to be able to affect processes you don't own, and the proc prio control privilege, which you need to be able to raise the priority of a process rather than just lower it. So that's one mechanism that administrators and other users can acquire specific privileges. The second is the service management facility, or SMF. This is what we use to launch most services in the system. This is how daemons get launched, for example. And the service manifests specify the privileges for the programs that they run. So the example here is from the SAR daemon, actually, and shows that it really needs to run with just one extra privilege beyond the basic set, and that's the file DAC write privilege. It needs that in order to be able to write files in a directory that it otherwise couldn't write to. And but other than that, it can run with no special privileges. And so that lets us, as I said at the beginning, severely constrain the extra privileges that this process runs with. And we can very conveniently control what that set of privileges is just by editing the service manifest. So the last slide is something I mentioned at the beginning when I said root's not special anymore. That's almost true, except for the fact that existing software assumes that setuid programs will run with all privileges, and that means programs that were written with that environment in mind, we still want them to work correctly. And they also assume, as we talked about a little bit earlier, that changing the UID will work to cause privileges to turn on and off, that they can use the UID as a way to control privilege bracketing. And so for compatibility, what we do is arrange that UID 0 gives the process all of the privileges from its limit set. Remember I said the limit set is the upper bound of all the privileges that this process and its descendants can ever have. So you can't ever have more than that, but we can, a program running as UID 0 can have all the privileges in its limit set until it becomes privilege aware. And when a process calls the set ppriv system call, we know that it was written with knowledge of the privilege system, and therefore we know it's a privilege aware program. Once process is privilege aware, then what I said on the first slide is true. That literally UID 0 is not special, just another user ID, and nothing matters other than the privileges. But processes that haven't demonstrated that they're privilege aware for compatibility still treat UID 0 effectively as having all privileges by giving it all the privileges in the limit set. What this means is a set UID root program is another method to gain privilege besides the two I just mentioned, besides RBAC and SMF. The other way for a program to gain privilege is to be set UID root. Before it ever calls set ppriv, it will be privilege unaware. So it will start with all privileges, and then it can turn off the ones it doesn't need by calling set ppriv, hopefully in the way I showed a few slides ago, turning off the privileges in its permitted set so they never come back, and then that lets it go forward with exactly the privileges that it needs. And that is everything about Solaris privileges in 7 slides. So, thanks. Yeah. Oh yeah.
I have a.
Yeah. For the record, here I'll put the microphone in your face.
All right. My question is. I have a shell script that needs to do mount NFS, and it wasn't easy for me to figure out how to find that privilege. That I could find the mount, but I couldn't find the NFS part.
Oh, you mean how to determine which privileges it needed was the problem?
Exactly.
Okay. Yeah. So a couple of things you can do there. One of the things is if you run a command using truss. It's enhanced to show you when a system call fails. It'll tell you it'll tell you why. It'll tell you what's
So what. Run it as root, trust it, and then figure it out.
Right. Yeah. So you could use trust to see the privilege is missing. The other thing, the Swiss Army knife of privilege debugging and configuration manipulation is the ppriv command, which you've probably seen. That shows you the privileges that a particular process has. In all of those 4 privilege sets. Also can be used to list the descriptions of the different privileges, so you can see exactly what the 75 privileges on the system are. But for the thing that you're talking about, the really useful thing is a privilege debugging mode where it can be used to, I think it's a capital D option if I remember right, but check the man page, where it will it'll show you every time it needs to use a privilege. It will tell you what privilege was needed to do this operation, and so that would be probably the easiest way to trace what the program is doing, what privileges it actually requires.
Awesome.
So.
Yeah, ppriv-e-capital D. There's another tool you can use. It's called privdebug.pl, Perl script that Glenn Burnett wrote, and that's very nice. You run it basically in one shell, and you identify the other process that you want to run, either by name or user ID or something like that. And as you run the other program, it shows you which privileges are used as they're used. And if some are missing, it tells you which ones are needed, which ones are not available. So just use and needs.
Right, and that priv debug Perl script I think is available somewhere on OpenSolaris.org. It's not built into the OS anywhere, so you'd have to go get that off of OpenSolaris.org or something. Ppriv is a regular thing in user bin, so you can find it there. Question over here?
3 questions. Actually.
3 questions. All right. Well.
Question number 1. So this is a process level control. You can't assign it to specific objects or I can't say not allow certain ports to be controlled by this process, or it's just a process grain sort of control?
Right. So everything I described here, a process either has this privilege or not, and so therefore it applies to any object you might apply to. Having said that, you'll see some OpenSolaris projects out there that look to extend that. Okay. That metaphor further to do exactly what you're talking about, to specify the particular objects, which files, which ports, which, depending on the privilege, whatever object it applies to.
Okay, so I can't do it in a specific thread. It's strictly in a process, right? Yeah.
That's the other thing. Actually, it's a good point. I probably should have mentioned and this of course is true of UID manipulation as well. That's a process attribute, and therefore not really safe to be manipulating your privilege sets in a multi-threaded program, because of course it affects all the threads in the process. And so no, you can't really manipulate this on a per thread basis.
Okay, great. Question 2. That was 1B.
That was all question 1?
Yeah.
All right.
1B. Question 2. I've noticed when I upgraded recently to S10U7 that the SMF XML files had privileges. Has this been backported back to 10 at all, or is it strictly in Nevada, Indiana?
It's definitely in Solaris 10. In fact, that's where this privilege mechanism started. Was first implemented in Solaris 10, okay. and so SMF from the beginning has had this mechanism to control privileges that way. Same thing with RBAC. Actually, RBAC is even older than the privilege system. RBAC goes all the way back to Solaris 8, but it used to be the only attributes you could control were user and group IDs. Now you can control privileges as well.
Okay. And I forgot what the third question is, so you're off the hook. So thanks.
All right. Well, thanks for the questions. Anybody else? Okay, thanks.